Okay guys, now the next we will learn how to check the uh, okay, now we have different tools. In the first tool we have learned these things. Okay, we learn how to design brake and the cylinder and many things. Okay, and also we learn how to pick options. Okay, like this. Okay, now we these things will be covered in the lecture 3. Okay, when we simulate the design. Okay, and in the post processing we also learn this result template in the antenna designing lecture 3. Okay, okay, now what should we learn? Okay, now let me create a shape here. Okay, like I want to make a shape of the square. Oh, okay, like this. Okay, so we have the length, width and the height, and 1.6 millimeter, and FR4 substrate. Okay, this one. Okay, so to make its color visible I am using different color. Okay, and also you can change the color and the material. Okay, from here you can load the material and change the color. Okay, and to change the color you can change color from this position. Okay, I set blue color so that it can be more visible. Okay, now if I create a feed line here. Okay, like this, minus wf by 2 width of the field line. Okay, and the length of the field line, because you see vmax lf, and vmax it will be only in the upward direction, because we need field line only in the upward direction, not in the downward direction. Okay, and write 0.035 preview, and it will ask you I select 2 and the length of the field line is 5. Okay, and you can see here this is your field line, and it is made of, should be made of copper. Okay, copper annealed. Okay, okay, so you have the field line. Okay, like this. Okay, now I want to create a port here. Okay, in CST there is a automatic option where you can create a port. Okay, like you need to go to the home, go to the macros, and you need to go to the solver, and then you need to go to the ports, and then click on the calculate port extension. Okay, coefficient. Okay, now you can see I click on the calculate. Okay, and click on the construct port from the pick point, and you can see it has automatically set the port here. Okay, okay, now what should I do? I need to, okay, this parametric and optimizer and the time domain solver and setup start simulation, we learn these things in the lecture 3. Okay, because in the third lecture we will discuss about the antenna design procedure, where we will simulate design and do different things. Okay, now we will learn how to set the line impedance of 50 ohm. Okay, so let me delete this port and let me select the surface here. Okay, now I will go to I go to the macros option. Okay, and then click on the calculate, and then click on the calculate analytical line impedance. Okay, okay, now suppose I want to design antenna at 2.5 gigahertz. Okay, and I'm using FR4 substrate, and the epsilon value of the FR4 substrate is 4.3. Okay, so if I click on the calculate, you can see your line impedance is 20 ohm, but we need 50 ohm. So how can we, okay, how can we set it 50 ohm? So we need to, if we decrease this one, what is d is the diameter of the length of the field line. Okay, and the 2 is the outer diameter of the core. Okay, So if I reduce its value, then it will increase the line impedance, okay, like this. And if I set at 0.25, you can see it is 60 ohm. And if I increase this diameter, then you can see it will, okay, we need at 50 ohm. So you need to vary the values and you need to set at 50 ohm. Okay, now you can see it is 50 ohm. Okay, in this way you can find or calculate the line impedance, not only for the coaxial probe, you can find for everything you want. Okay, you can see there are so many options. Like for the CPW, you can see there is a field line at the center, and there is a ground on the left and right side. Okay, so you can also set the line impedance. Okay, and if you increase the width of the field line and decrease the gap, then your field line line impedance will be at 50 ohm. Okay, suppose if I increase the width of this field line and decrease the gap of 0.2 and click calculate, you can see it is very near to. Okay, so you can write here. Okay, this one. Okay, you can see now it is at 50 ohm. So how it is 50 ohm? If you keep the gap 0.2 millimeter, okay, and the width of the field line is 1.6 millimeter. Okay, so this is important to know. And also you have many options like this. Okay, and strip line, coaxial probe. Okay, you have many options, so you can find uh, very easily the line impedance. Okay, so this was the method to let you know. Okay, now you can use the calculator to calculate or do multiplication or calculate the values. Suppose 3 for cross, you can write 3. Okay, click calculate, it is 9. Okay, so 2 plus 2 is equal to 4. Okay, you can use this calculator for quick calculation. Okay, and I click if I want to create any shape here. Okay, like I can use this curve. Okay, like this one. If I zoom it with mouse, okay, and double click on it, and you can see your outline will start. It is just like a draw a shape on the paper with a pencil. Okay, so you can design any shape that you have in your mind. Okay, okay, let me design any shape. Okay, you just keep in your mind that the starting and ending point should be the same. Okay, at the same position. Like let me complete this. Like this one is my, this is my starting point, and this one is my ending point. So I am going to connect this ending and a starting point. Okay, just double click on it and you can see like this. Okay, so it means they are joined right now. And also you can change the values or dimensions here. Okay, like you can select any point, like I want this point, and I can change its value. Okay, and you can see this is u direction, this is u, and if you are putting minus value, then it is will be opposite side. Okay, means it will be if I increase the value, it will go to the right side. Okay, like this, like sorry, left side, like this. Okay, and if I write 7, then it will move like this. Okay, and if I want to move up, you need to increase the value of the v. Okay, like 4, and you can see it is going up. Okay, so in this way you can also uh, set the dimensions. Okay, now when you have this shape, okay, then you need to go to the extrude curve. Okay, click on it, and if you click your mouse on it, you can see the color is now changing. So when it will be yellow color, then just double click on it. Okay, now you need to just write the value here and select the material copper. Okay, the thickness, standard thickness of the copper is 0.035, and double click click on it. Okay, and you can see here. Okay, now this is your shape. Okay, the other thing, how to cut the slots, or how to cut very small patches from this patch. Okay, like this is a patch, this one. Okay, so you need to, suppose I want to cut a patch, small patch from this point. Okay, so I need to transform my WCS. I just keep it like this. Okay, okay, now I want to, now my WCS is at this position. I can draw any shape here. Okay, I want to cut like a cylinder. Okay, okay, now click minus 0.035 and select copper and click OK. Okay, now to cut this shape, this circle from this shape, you need to first select this whole shape, then go to the subtract. Okay, click on it and then select the circle. Where is the circle? This one. And now press the enter of the keyboard. I am pressing enter, and you can see in this way you can cut the shape. Okay, press Ctrl Z to undo this. Okay, now I am want to combine this circle and this patch. Okay, so what should I do? I need to click on this, select this surface, go to the boolean, click add, and then select this circle and press enter, and you can see both are added up. Okay, so there is no change now. In the now I want to cut the slot from this position, but at an angle of 45 degree. So what should I do? I need to transform my WCS. Okay, like this, and I need to rotate. You need to click on the rotate. Okay, select the 45 degree angle. Now you can see this is 45 degree angle, and click on it. Okay, now you need to go to the brick. I select any dimension that you want. Okay, like this. Okay, if you want to cut in this direction, okay, in the U direction, then you can write here 0 minus 3 and 3. Okay, where is the U? This is the U, so you need to write here 3, 2 minus 3, and 0, 1. Okay, like this, and then click on the minus 0.035. Okay, and you can see this is inside the patch. Okay, now I need to select the whole surface, go to the boolean, or you can press the minus on the keyboard. Okay, I am pressing minus on the keyboard, and you will see option like this, and then select the slot. Okay, now press enter, and you can see this is cut now. Okay, okay, now in this way you can make any shape and you can cut very easily. Okay, and regarding the bending analysis, I want to show you once more time. Okay, for bending the antenna, you need to move your WCS on the opposite side of the substrate. Okay, so just select the lower edge. Okay, now select the all the components, and then go to the bend tool and go to the cylinder bend. Okay, now you need to select the both sided. Okay, and press preview to see. Okay, now you can see your antenna will bend like this, okay, like this. And you, if you select bx, no, this is horizontal axis, so I mean bending along x-axis, so you need to write here b bending and all along x-axis, okay, and click preview, and you can write any dimension here. This will be in millimeter, okay. Now you can see your antenna is bent along x-axis, okay. Press Ctrl Z to undo, okay. And now if I want to bend this antenna along y-axis, then you need to rotate your WCS at an angle of 90 degree, okay. Now again go to the bend tool, cylinder, okay. Now like this, click on the preview, okay, like this, okay. And for the vertical axis, you need to bend the antenna only one side, okay, because you will have a port at this point. If you bend also this side, then port will not connect with the field line, okay. So just make sure to bend the antenna for, along vertical axis, you need to bend only one side, okay. And you can write here by, okay, and click preview, and you can write here 5, okay. Press ok, and you can see your antenna is bent now, okay. In this way you can bend your antenna, okay. Now you will have an option like this, okay. If you want, you can write 15 here, okay. Now it will not change because I press the undo, okay. Okay, now you have learned how to bend the antenna, okay. Now I want to export the Gerber file of this design. First I need to align the WCS with the original axis, okay. Now you can see this one and this one is now aligned, okay. You need to align WCS on the substrate, okay. Now go to the export, go to the 2D files and click on the Gerber view, okay. Now press enter, and on the desktop you can save it, okay. You can save example patch, okay, like this, okay. And you on the desktop you will find like this, okay, Gerber file, okay. In order to want this to see this Gerber file, you need to install one more software. Let me show you. Where is this? Okay, this one, okay, Gerber v.exe, okay. Now click open this and then press on the plus sign, go to the desktop, and search where you have saved the file, okay. Example, this one, okay. Now click open, okay, double click on it, and you can see here, okay. Now you are not able to see, sometimes the fabrication do not properly do because of this reason, okay, because you did not delete the substrate, okay. In order to export the Gerber file, you need to you need to delete this substrate and just click the component, and then you need to export again Gerber files. Press enter and save it again, and now open again. Example dot this one, okay. And now you can see you have opened the Gerber file. In this way you can easily see your Gerber file in order to send, before sending the for the fabrication, okay. You need to install this one, Gerber v.exe, okay. Now I am pressing Ctrl Z to undo the substrate, okay. Now if you want to open this design in HFSS, or you're in an older version of the CST, you need to go to the SAP file and then on the desktop, and you can click you can save in many ways, okay. You can save in SAP file, okay. Now file 1, okay. Oh, sorry, you need to export, okay, SAP file like this. Go to the desktop, you can select the version, okay, any version. Suppose if you have 2000 15 version of the CST, you can write 15, okay, or you can go up to 25.0 version, okay. And if you have HFS version of 15.0, you can select 15.0, okay, and then write here the name, and you click save, and you will find a file like this, okay. So this is the file, sap file. You can import it in the, suppose I am deleting it now, okay. Now I want to import that sap file, okay. Now you can see here, and you can open in this way in any CST version, okay. Okay, now if you want to export the image of high quality of this design, okay, then you need to go to the view and then click on the export image, okay. And at the desktop you can save the image, okay. And you can see on the desktop you will have an image, okay, this image, and you can see this is of high quality, okay. In this way you can save the this, okay. uh, I mean, you can save any, like this, you can save this graph very easily, okay. Like go to the view and view options, oh sorry, export image, and then save at the desktop, okay. And you can see you will have high resolution graph, okay. In this way you can save it, okay. Now if you want to copy this file, graph, then you click on the copy view, okay, and you can paste into any word file, okay. Now I'm pressing Ctrl V to paste, okay. Now you can see you can paste the graphs here, okay.